This is the electron configuration, and it helps us know where the element is located in the periodic table. Here, when you use the electron configuration, you do the order by arrows. So the first one is 1s, 2, and there's a 2 on the top because the S has a 2, and then the P has a 6, a D has a 10, and an F has a 14. The numbers are the quantity of electrons each one has. So the S, which is for sphere, has 2 electrons. The P, which is for peer, has 6 electrons. The D, that is for derivation, has 10 electrons. And the F, where it's for function, it has 14 electrons. In here, when we were continuing, so when you do electron configuration, you start with the 1s and you have a 2, like here. And the 1s is first. And then you have the 2s. So you put 2s, 2. Next, you go like back and forth, back and forth. So you have the 2s, then you go on top and you have 2p6. Then you have the 3s2. Then you have the 3p6. And so on. The 4 is the highest energy level because it's, as you can see, it's 1, 2, 3, and you got it up until the 4. So the 4 is the highest energy level. And this is the period. And here, the number which you ended up, so 4 is the period. And the period is the highest energy level. And the thing where you end up with a P6, that is the group. And this is where you are locating the elements in the periodic table. So the period is a row, and this is a column, okay? This is the location of elements. To be able to do this, you have to know what is everything in an element. So right here we have iron. This is the atomic symbol. Fe is the atomic symbol. And then iron is the element name. On the top, on the left corner, is a 26, and this is the atomic number. The atomic number will help you know, like do the electron configuration and then find the location of the elements in the periodic table. So this is the atomic number. And then on the right corner is the atomic mass, the quantity of mass the element has. Okay. So then to find where the location of iron is, we have to do the electron configuration. So there's 26. So we'll start with 1s, and it has 2 electrons. So then we have 2s. We're trying to get to 26. So when you try to get to 26, you're adding all these numbers, okay? So then you have 2s2, then you go up to 2p6, then you go down to 3s2, and then you go up to 3p6, and then you have 4s2. So let's check how many, like the quantity we have. So 2 plus 2 is 4, plus 6 is 10, plus 2 is 12, plus 6 is 18, plus 2 is 20. So we have to have 6 more. And then we have 3d10. Right here we already have 20. And if we add 10, we'll have 30. So we want to have 26. So instead of putting on the 10, we put the 6 to have the 26. So we have 4, 10, 12, 18, 20, 26. And our last number, well, it doesn't have to be the last number because it's the top number, the biggest one. And the biggest number is the 4. So our period is 4, and this is the row, okay? And then the D6, the last part, it's the group. And this is a column, okay? So when you have the group, which is D6, you check on which 3B it is, because it's D6 right here, and you have 8B. So then, it's 8B, okay? What you really need is the 8b, but to find the 8b, you need the root, so you have to do the process. We said the period was number 4, so we go to the number 4, and the period is a row. So we go to the number 4, and then it says that the group is 8b, so we go like right 8. So we go 1, 2, 3, 4, 5, 6, 7, 8, and here's the iron. And that's how you locate the element. Okay, remember when we said that the highest point was the period? So here we have two highest points with their electrons, okay? So we have the 4, and then there is something called a valence electron that you will use, that these are the valence electrons to be able to locate the elements. So then, classify them. So then the valence electron is, from the highest points, you add them up. The highest is 8. You can't have a higher valence electron than 8. If it's greater, it's not a valence electron. It isn't able to have that. Okay, so then here we have 2 4s. And then you have the 4, you have the 6, and the 2. So you add them up, and you have 8 valence electrons, okay? And then since this is in the section P6, so it's right here, so it's 8A, and then it has its noble gases. Okay, so it's right here, so this would be a noble gas. And then, for example, if we only had it up to here, then our greatest number would be 3. And then we would also have here these two, adding them up. So then we will also have 8 valence electrons. But then, if we have more, so another example is that now we have more numbers, like we had a bigger number, we had a bigger element that had more atoms. So then here, our biggest number is 5. And since there is no other 5, you don't have to add any electron up. So then our valence electron would be 2. And then right here, our last number is D10. So then it's right here, and we have 2 valence electrons. So then this would be a transition metal.
Okay, now we're going to see the classification of elements. And as you can see, this is the table of classification of elements. And here, as you already know, S1 and S2 are located right here, and S1 is alkaline metals, and S2 is alkali earth metals. And all of this big space are transition metals, which are the letter D. And here, as you can see, are the P. So P1, P2, P, okay, and so we go on. So you can see that this part is circled. Why? These are called metalloids. And so now we're going to make an example of a metalloid. So we're going to choose boron. Okay, so here we do the electric configuration, and as you can see, its group is P1. So you find P1 and you see that it's located right here and it's a metalloid. And for example, these ones above silicon and germanium are nonmetals, and below them are other metals. Above astatine and antimony are nonmetals, and below all the elements that are below them are other metals. And here, tellurium and polonium, above them are nonmetals. And then we go to P5, which are called halogens. And as you can see, here's astatine, and it's also a metalloid. And the last group is 8A, which are noble gases. And now, thanks to this explanation, you can know how to classify elements.